Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada, the engineer. With me, Mr. Lady Ada on camera control. Yeah, jam-packed show for you. Tonight, 1 hour of making, hacking, coding, soldering, knitting, welding, drawing. I don't know, all sorts of making stuff going on. New products, lots of videos, and more. Mr. Lady Ada, why don't you tell them the code and what's on tonight's
Yeah,
show?
tonight's code is cams, 10% off an Adafruit start, all the way up to 11:59 p.m. Eastern Time. Use it or lose it, everything except for a Raspberry Pi unit. Talk about some of our live shows, including Show and Tell. We'll do a little bit of a recap from Desk of LadyAda, including the Great Search. Highlight from JP's product pick of the week. Forget JP's workshop is tomorrow. We have some advanced manufacturing made in New York City factory footage. We have some 3D printing. We've got Item PI this week, brought to you by DigiKey. This week it is Bridge Tech. We got a bunch of top secret videos. A lot going on behind the scenes. Some new products. Answer your questions. We do that over in Discord, adafruit.it/Discord, where we can answer your questions. Put them there. We'll also get to them throughout the show, but mostly at the end.
Go to Discord.
Yeah, all that and more on, and you guessed it. Ask an engineer.
Oops, did we forget that?
Yeah, I had multiple graphics.
This and then the thing is everything is black and white, so it's like you're like, which graphic is it? I don't know because we just wore black. Okay.
Yeah. All right, so we got a few things going on. Wanted to first up remind folks, if you use the code, there's free stuff. LadyAda, what do they got?
That's right. When you order from the Adafruit shop, you can get $99 or more a free PCB coaster with a beautiful gold design on it and matte black solder mask and little bumper so it doesn't scratch your desk up. $149 or more, you get this Pro Micro pinout compatible RP2040 board. It's designed for keyboards, but it's actually good for all sorts of microcontroller projects with a powerful RP2040 chip and STEMMA QT port. $199 or more, free UPS ground shipping in the continental United States. It's trackable, it's insured, it's brown, it's UPS. That's their new
Yeah.
And then still we have plenty now. Circuit Playground Expresses. I know we missed these, but it's back, our classic giveaway. $2.99 or more, you'll get a free Circuit Playground Express, our favorite microcontroller board that's perfect for learning programming.
Yeah.
Because it's got LEDs and buttons and sensors all built in, no soldering required, and lots of drag and drop, Python, Arduino, programming languages available. So it's an excellent start whether you're a youngster or a youngster at heart.
Okay. So in addition to all of that, don't forget the code is CAMS. But there is one thing we want to mention once again. We're doing this. So if you have an Adafruit account, please verify your account, use two-factor authentication. The reason is we're doing some Raspberry Pi 5s again tonight. This has been working out. I'm going to do a little bit of news about AdaBox because we have good news. Things are still moving along. I wanted to give some folks some updates. So while I'm doing that, LadyAda is going to put in some Raspberry Pi 5s, 4 gigabytes, and you'll see those soon. So get ready. LadyAda, why don't you go ahead and start doing that?
I'm escaping.
Yeah. So here is the AdaBox news for now. Here's the plan, everybody. Plan is for us to ship some of our AdaBoxes this year. What we're going to do is contact some of the subscribers. We'll probably start with the ones who've been with us from the start. Say, hey, we're getting ready to ship some AdaBoxes soon. We're only going to email a small number, of course, because we don't want to get everyone hopes up, and we know that it's going to take some time because it's been a while since we shipped an AdaBox. We basically had to redesign the AdaBoxes with a new world where there was no parts available. So if something used a specific type of part, we had to completely redesign it, make sure that times 100 different parts. So you'll get an email if you're an AdaBox subscriber. It won't be all the subscribers all at once because we don't, again, want to get everyone hopes up that it's going to ship immediately. But we'll have a AdaBox for folks. Email from us. We'll ask you to make sure your payment information is updated. We don't charge until we ship, unless it's a prepaid. And we'll then be able to give you more information about when we think we're shipping. We're probably going to ship some shortly, and then beginning of the year we'll get caught up to all the AdaBoxes that we didn't get to this year, and then hopefully we'll be doing an AdaBox a quarter again. We'll see. Everything in the store. All right, so the Raspberry Pi 5 are in stock. Let me go over to the handy dandy web browser and see if this is true. They're in stock. So if you want, you can go to product ID number 5812. You can also type Raspberry Pi 5. You can see the 4 GB models. They're in stock. LadyAda is on her way back. We will continue with the show shortly.
Okay.
But
sorry for that delay.
That's all right.
I wanted to notify and blah 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 and all this stuff. Okay.
So anyways, I was telling everybody about AdaBox. So
yes,
gonna ship a small number for the end of the year, and then larger and larger amounts as the year hits. We should be able to get all the AdaBoxes out soon, but that's our update. Good news, everything is available. We'll be able to do this. Now we have to make sure that we can get everyone's.
We did get the first order of PCBs.
Yeah, we have to make sure we can get everyone's payment information updated more. It's been a while.
Oh, it's going to be.
It's been a haul. So we're going to start slow, but
we're still doing it.
Not
promise.
Not giving up. Okay. And then some. By the way, some people are going to drop. They're going to say, "Oh, it's been a while. I decided I'm going to do other things." So just make sure you sign up on AdaBox.com. You get notified when you can sign up for AdaBox because we'll have some openings, I think.
Probably.
Okay, we do a bunch of live shows, including show and tell. Thanks so much, JP. JP did the show and tell this week. Next week we're on holiday week. We're doing it, so come by next week, 7:30 p.m. Eastern time.
Yeah.
And show and share whatever projects you have, retro stuff,
turkeys,
pretty much anything else.
Cyber turkeys.
Yeah. But Sundays we do from the desk of LadyAda. It is in 2 parts. Usually LadyAda is showing what's on her desk. What did you show in part 1? Last week.
Okay, so I didn't have a working live demo, but I tried. What I've been working on, we do have the 1-minute videos at the end of the show, which will show off the stuff in working mode, is getting the round and bar and square displays all working on a Raspberry Pi using an ICN 6211 to convert the dual DSI ports on the Pi 5 to drive these screens. And it's been a joy. So we have to, configure the SPI for the display. We have to configure the I2C for the ICN 6211, and you have to configure the device tree overlay for the kernel module changes that Timon has been doing for us. Getting all 3 pieces all working means that we have a beautiful image on the display. So, while I wasn't able to, whatever, my board stopped responding, because I think it's actually static, by the way. I think I have to turn the humidifier on because I've been frazzling boards a little bit more than usual. And I'm very not careful with them. I'm licking them and like filthy hands.
Don't do that.
Yeah, I know. Don't lick the electronics. But I'm making a lot of progress with this, and hopefully we're gonna get that kernel module merged in, and at least that way we'll have. And I'm going to revise the board to have an onboard EEPROM, and so we'll get that family of breakout boards out the door for the end of the year.
Okay, and then we do another segment. This is called The Great Search. This is when we help you find things you need to find. We usually get tagged, or we'll also, there's folks that are just looking for stuff online and we're like, oh, here you go. We can help.
I do like to do ones, I have chips that I'm, searching for, but I'm kind of always searching for the same sort of stuff. And I thought it would be neat to see what other people are looking for online. So sometimes I look for the phrase like find, DigiKey, or search, or whatever. People are looking for something. And this person is a ham radio person who's looking for terminal strips that have little nubs terminals on both ends of the strip. And so I've never used these before, but I've seen them in ham radio kits. They're used for free wiring. So I showed how you can use a data sheet to find which configuration you want and then use that to purchase it on DigiKey.
Okay. Do that every single Sunday. Stay tuned for Desk of LadyAda, including the research this week. And we do JP's product pick of the week every single week. Here is the highlight from this week.
There is my product pick for this week. It is the AD5693R 16-bit DAC breakout board. You can tell it to send really accurate, really fine-tuned, fine-grained voltages. I am telling the DAC right now to send out 1 volt. And you're hearing that the 1 volt is being used by my little synthesizer off to the side to tell it what note to play. There you can see we get a really nice smooth. You can hear it better than you can see it on my multimeter just because it's a digital meter. Now I have it stepping down. If I go to a different type of effect with it, you can see we're sending out some really cool stuff. It is the AD5693R 16-bit DAC breakout.
Okay, and then on Thursdays, we have JP's workshop, a little programming note next week. There'll be no JP's workshop because it's Thanksgiving. And then this Friday, there's Deep Dive with Tim. Probably not next week. I got to double check, but you'll be able to figure out soon. Check all of our social places, most likely Discord.
Week afterwards.
Yeah, we'll see which shows that we're gonna have. We'll have the full schedule as soon as we figure out what everyone's doing. Let's do some Python on hardware. Okay, some highlights from this week's newsletter. If you're into Python, every year there's the official Python developer survey. Please, please, please consider filling it out. It helps them figure out what things the Python Foundation and the folks that are driving all the interesting things in Python do.
Well, JetBrains, they have the most popular editor for Python. So these are, if you're using Python daily and there's like stuff you want Python to focus on, this is your chance to learn.
Including things that are helpful for CircuitPython, because it's all part of a core. There's Python,
yes,
and then there is MicroPython, and there's CircuitPython. It is all a big family. So if there's something in Python, we'll probably have it in CircuitPython at some point. You can check out the rest of the projects. This week we're going to do a couple things. We're going to talk about something from Playground, and we're also going to play a video. This is the Making Music with CircuitPython and Raspberry Pi. We try to highlight some of the things from the community. This is a really well put together, so we're going to play well put together video. So we're going to play this. It's from Pensacola Maker Faire. You can see.
It's cool that like Todd, JP.
Yeah, if you're looking to do anything with music, you can check out this really neat Pico Sandbox demo and more. So do check out all the projects. You can see all the things that people are doing with Python on hardware.
Yeah.
Pretty much anything that you can imagine, it's here.
One thing I thought was interesting at the beginning, I forgot that it was in the newsletter, is, GitHub had this big announcement about how they're like, or their next generation of GitHub is going to be all Copilot controlled. And I thought that was interesting because a lot of people do use, Copilot, particularly when they're using CircuitPython, because one of the benefits of the way Adafruit works is we've been publishing thousands of guides and projects and tutorials and examples. And so not only is there documentation, but there's so many examples that chances are, if you want to build something with CircuitPython, Copilot will be able to do a pretty good job because it already knows all of the styles that we have for Python.
You can even interact with some of these AI systems, ChatGPT being one. You could be like, I want to write a library in the style of Adafruit, and it used our code, and it will, because we allowed it. And I don't think Genie's
it's trained on it.
Yeah, it's too late now. And so you'd be able to write libraries with an Adafruit style as well. So do check that out. But let's go over to Playground, because you wanted to talk about this. This is using Android with CircuitPython.
Yeah, Liz just published this. This is thanks to PR. Can you click on the PR merge in CircuitPython? Because I want to get the person's name correct. Who did it? It was ADCC. It did an excellent job. They're fixing up a bunch of our mass storage, not bugs, but just like stuff that can be improved. And one of the things that they updated was the like a couple bytes in like the fat format MBR now lets Android mount the file system. And so you can have like an Android phone or tablet, plug in your Circuit Playground board, the mass storage shows up as a disk drive, and then you can open up, there's a bunch of free editors that Liz talks about that you can use to open a file, edit it, and save it. She gives a couple of hints. There's one way that works great and one way that does not work very well. But once you got it working, you can also use the REPL to connect to the serial port as well. So you can basically have a portable, no computer required
That's cool.
programming system. And like, it's funny, a lot of the things that I, the decisions that we made with CircuitPython come directly from me having the frustrating experience of having to debug PIC microcontrollers at Burning Man. And it was just unbelievably infuriating to like, oh, I didn't, I don't have the right driver. I don't have the right IDE. I don't have the library. I don't have internet access. So being able to edit and tweak code on the fly using any computer or now any mobile phone, I'm getting close to making me 10 years ago happy.
All right.
15 years ago.
So
me
check that
happy.
out. And the way to get to that is if you just go to learn.adafruit.com and click Playground, you'll be able to see this and so much more. Playground is a place where anybody can publish guides. Our team uses it, community uses it, lots of great guides and more, probably some familiar faces from the community. But this is where we put ones that
Join in.
Yeah.
Write something up if you want. If you're working on a project, and then when you're done, click that you want to show and tell the project, and we'll feature it on the front page.
Okay. And then getting back to what I was talking about before.
Yeah, sorry.
This is a great, no, it's okay.
That's right.
This is a really good video that was sent to us. So we're going to play this. Check it
Synth.
out. Synths.
Snakes.
Hello everyone. I'd like to present to you today a little project I've been working on called the Pico Synth Sandbox. Name pending. After playing around with the new audio synthesis library, Synth.io for CircuitPython, which came out earlier this year, I became very aware of both the power and limitations of this awesome new tool. In order to add nearly all the functionality that you need and make the process of programming your own musical device extremely simple, I decided to create a new piece of hardware using the Raspberry Pi Pico and team it up with a fully featured new CircuitPython library to get you off the ground running. The Pico Synth Sandbox comes with nearly everything you need to make a variety of synthesizer projects. First and foremost, we have the star of the show, the Raspberry Pi Pico, which holds 256 kilobytes of RAM and 1 whopping megabyte of onboard flash memory to store your code. Next, a 12-key capacitive touch keyboard with full polyphony, but sadly no velocity or aftertouch. Then you have the choice between I2S or PWM audio output, depending on your preference and budget. One of my favorite features is a teeny tiny PDM omnidirectional microphone for you to record your own samples. And up front and center, we have a 16:2 character LCD display with a rotary encoder to handle any menu diving you might need for your project. An absolute must-have for any musical device is hardware MIDI input and output. In this case, we're using 3.5mm jacks to send these digital signals. To hear your sound creations, we have a volume knob with both 3.5mm line level and onboard speaker output. Last but not least, we also have a LiPo battery to power it all. In its current form, not every feature can be used simultaneously and has to be pre-configured beforehand. This device is still in its revision 1 infancy, and there's much to improve in future board revisions. Many examples are available that show off how easy it is to get started with this device and the included hardware abstraction library. Here are a few of my favorites. A bass-heavy monophonic synthesizer. A complex, filtered polyphonic synthesizer. An analog-style drum machine with a 16-step sequencer. And a fun sampler using recorded audio from the included microphone. Hey! If you're interested in trying out this fun project for yourself, the PCB Gerber files and bill of materials are available on the GitHub page down below in the video description, as well as a quick getting started guide to get your Pico set up with CircuitPython and the Sandbox library. There are plenty of examples and library documentation on the Read the Docs site included below as well. And if you happen to be in the Pensacola, Florida area this upcoming weekend, November 11th, I'll be set up at the 2023 Pensacola Maker Faire to let visitors get hands-on with this device and learn about CircuitPython and digital audio synthesis as a whole. Thank you all for letting me share what I've been working on lately. I hope you have a wonderful day.
Okay, so for all of your Python hardware needs, you can sign up on Adafruit Daily, delivered each week. Spam free. We hate spam even more than you do. It's a completely separate website. It has nothing to do with your shopping account because we want to make sure that you knew that we just don't send you newsletters. So adafruitdaily.com setup is for Python on hardware. Okay, let's do some. Oops,
Wait, do you
remember.
want to check on the Pi? Or is it...
Oh, you want to check on the Pi?
Well, we don't know how they're doing.
Let's go check on the Raspberry Pi and see how they're doing here.
So we're in between segments.
We are. So let's go over. So we interrupt this open
Beep, beep,
source
beep, 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 beep,
hardware.
beep. Wait, it's over there, yeah.
Yeah, to bring you. Let's see. Let me hit refresh. Okay, we have
60.
60 in stock. So
Plenty.
if you're looking to get a Raspberry Pi 5, this is probably it. I did see folks online. Social media is essentially for complaining, or even worse now. And the consensus from folks seems to be the pre-order thing, because there were so many people who pre-ordered and now they're just waiting, and there wasn't enough to go around for these pre-orders, that they're contemplating doing something else. So,
Yeah, I mean, the Pi Foundation has allocated a certain number, which every company has a slightly different allocation. But just because you got more pre-orders doesn't mean you get more.
You get more, yeah.
Yeah, it's like you get the number that you were allocated was actually
So-
given to you before the release. So
there's no perfect solution. There's just some things that are least worse, and so we think we found this. People have been
it's a
happy.
bad thing.
Yeah, and like we've been releasing them, and you kind of know that we're doing it during the shows.
Yeah.
So I would say, especially as the holidays hit, this is probably a good time. If you haven't already.
Oh yeah, if you want to give one for the holidays, yeah, I don't know. I actually don't know that we'll be getting more after
We don't know.
November. So
We don't know. Okay.
Good
So
luck.
anyways, some open source hardware news. Congratulations, LadyAda. This was last week. GitHub did some awards, and you got an award.
yay,
Yeah,
hardware.
hardware hacker.
That's me.
Yeah, that's you. So you got this GitHub award. I don't know what the criteria is. I'm gonna guess. That's why I put it in the open source hardware section. Adafruit publishes all of their designs under an open source license. It's on GitHub. It's available. There's code. There's the files you can download. It's working out. We understand that there's a lot of things that say they're open, but they're not. But that's on us. So special thanks to the recognition from GitHub. Congratulations. I know you just did a massive round of new designs, and they're all open source hardware.
Yes.
And we're always going to do open source hardware because we said it so many times. You can do a supercut of it on the times we said it.
We're like, somebody should make a video every time we say open source
Open
hardware.
source hardware.
Yeah.
So yeah, and I think that's one of the things that's important to folks out there who are shopping. You have choices, and you get code, you get all the things that make the hardware go. For a fact it's always yours, and you know that you can inspect it and improve upon it and learn from it, and that's unique and rare in this world.
Oh boy, is it ever.
So speaking of, let's go to the learning system.
Yes.
And what's on the big board this week? Do we need to refresh anything? No.
No, yes. So this week, we have a new guide from Noah and Pedro, the quality of 3D printed cases. If you've been checking out all these square, round bar displays and you want to encase them, like once you've got your project up and running, they made a lovely case that can mount this touchscreen or non-touchscreen versions and a qualia board. And then, of course, you can attach sensors. You can have I2C or SPI, so you can add more electronics if you need to, or just have it just display cool round things. We have a round display. We also have a guide for the ADS 7838-bit 8-channel ADC. Simple ADC, but useful. We have Arduino and CircuitPython code. Liz Clark wrote up a guide, also did the CircuitPython library port. we've been updating a bunch of the Adafruit IO guides. Brett has been just cranking through them, and did the basics guides, and he's done a couple other guides, and then I believe the power wash controllers. I know that video went out like 2 weeks ago, and it kind of flew by my to-do list. It's finally up, so if you wanted to build that product from JP, it's now published. And thank you for your patience.
Okay. And then we also mentioned this before, but we have our playground.
Check out Playground.
Yeah, so like
Click on Playground.
Yeah, learn.adafruit.com, and then we have adafruit-playground.com. You can go there too. And you can see all the latest guides. Some of them are like remixes of some projects that we have, and then some of them.
But that's great because people are always like, "Oh, like I want to write a guide, but I just want to make an adjustment to an existing one." And I'm like,
Yeah, these are really cool.
perfect.
So,
Perfect usage of the playground.
And for the folks who pay attention to stuff, we wanted to have a place that people could publish their to-dos, how-tos, things that are important to them that they're building, but allow everyone else to see them. So, you can see these without having to log in. We don't have any type of weird thing that you have to pay or tracking. Like, we try to make sure that this is the least worst place to publish something that's important to you. And a lot of folks wanted to take a tour in how we use our Learn system, but they want to do it for their own stuff. So we're like, okay, here's a way to do it. So we're calling these notes Simple Playground. Check it out. Okay, let's do some factory footage. Next week's factory footage. Okay, let's do some 3D printing. We're gonna play these back to back. We have 2 videos. And Pedro, get into the holiday spirit too. There's a lot of stuff going on with that. Don't forget to tune into their shows on Wednesday. 3D Hangouts live every single week. Let's play it.
You can power RGB TFT displays with the Adafruit Qualia ESP32S3. Featuring a built-in RGB display peripheral, this ESP32 dev board comes with 16 megabytes of flash for buffering large images, animations, or even video. It can power a big 4-inch 720 by 720 round display for making projects with a unique shape. Included are pins for a capacitive touch overlay so you can have touch control with supported displays. 2 built-in side buttons can be used for user input, such as interfacing with the display's brightness or cycling between modes. CircuitPython support makes it easy to write software using the Display I/O library. Demo code is available for initializing various display sizes so you can quickly get up and running. The product guide features documentation for getting started with both Arduino and CircuitPython. You can set constant current for the backlight control circuit using the onboard jumpers. You'll want to reference your display's datasheet for getting the correct voltage. We designed and 3D printed a case for this 4-inch display in an all-in-one snap-fit enclosure. To Translucent PLA lets you see the Qualia ESP32S3 dev board, reminiscent of gadgets from the 1990s. We also designed a snap fit case for this 4-inch 480 by 480 square display. This features 3D printed buttons using flexible TPU filament for easy button actuation. A built-in recess section allows for easy access to the buttons and the USB-C port. We think the Adafruit Qualia ESP32S3 is the best IoT dev board for exploring these RGB displays and hope they inspire you to create new projects.
And that's 3D printing of the week. Let's go and find everybody. Cam's discount code, don't forget, it does not apply to Raspberry Pis. Let's do a Raspberry Pi check-in.
Oh.
Let's see how many we have left.
Beep, 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 beep. Refresh.
44 left in stock.
Still quite a few.
So 44, you still have time if you have not already set up your account and got two-factor authentication. But even if you run out of time, it's okay. Do it now, though, because the next time we put these in, you'll need to do that anyways. Let's do some Eye on API.
Eye on API.
Eye on API brought to you by DigiKey and Adafruit. Thank you, DigiKey. Rich Tech, is it
That's right.
your power partner?
There's a power partner.
That's right.
We've covered them before. This is their second time on the show. I think we did an LED driver from Rich Tech before. They do a lot of automotive, a lot of industrial. This week we're going to be looking at an I2S audio amplifier. I do love I2S. This is a similar chip, but they didn't have an image of the package, but this is it. It's the RT9120S, particularly S, and this is an image of it on the eval board. So you can see it's like a, a 24 to 28 pin QFN, and it's a very powerful I2S amplifier. Despite this being a tiny little chip, this is a, this is the wrong screenshot. It's a 30 watt, not 20 watt, because it's the 9120S. It's a 30 watt stereo inductorless I2S input, Class D amplifier with stereo or mono output. Like halfway through, I realized that there's the 9120 and the 9120S, and we're actually talking about the 9120S. That's the new version of this chip, which is more powerful. It's pin compatible. So if you have been using the 9120, just FYI, it's the same, but better because it's got better specs. So the 9120 in general is an I2S amplifier. So it's digital input, analog output. It drives a speaker directly. It can do stereo or it can do mono. The I2S signals can be 1.8 or 3.3 volt input, but for the power to the amplifier part, you'll need 5 to 26 volts. And I like that because that's a nice wide range. If you don't need the full 30 watts, you can do less than, we'll show the power rating. You can do 12 volts or less, but if you want to use an automotive or industrial system with 24 volt power, you can power it with 24 volts, no problem. And because it's Class D, you actually have very little power dissipation issues. Like most people who are used to amplifiers that are dealing with 30 watts, you're going to have a gigantic heat sink on your Class AB. Not necessary here because it's a Class D amplifier, so it does, I think they have this spec here. It's like 1.5 megahertz PWM. It's like I think it's either 75 or 1.5 megahertz. And this chip can also do a variety of different inputs. I2S, right justified, left justified, and as well as TDM. Okay, so this is actually made a little mistake. So the one we're talking about today is actually the RT9120S. You can see that they are almost identical, same 32 QFN. The 9120 is the older version, 20 watt max. The new version is 30 watt max, but otherwise they still have stereo output, 4.5 to 26 volts. I believe they have almost identical I2C command set. It's also the 21S is a little bit more efficient. It's got 94% rather than 92%, and it supports TDM, whereas the previous version did not support TDM. But there's also other power amplifiers, by the way. So it's like, oh, you want, higher wattage, lower wattage. You can, there's a, a wide range from Rich Tech. We're just going to be only talking about the 9120S here, but they do have tons. So how do you control it? Well, you can give it I2S input, and one thing, and then I2C to control it. So you will need a driver. It doesn't have like a free run mode. You can't just pipe I2S in and have it just automatically output audio signal. But the I2C is at least well documented. There's a full register map inside, and then there's like a fault output, and there's some power supply stuff. But it's actually like a fairly simple, what I like is there's not a lot of extra components needed. Like you don't need an extra crystal, you don't need M clock input, you don't need a PLL, extra capacitors and inductors and whatever. It's very much like data in, audio output. So one thing that I do like about this is that, if you're wanting to use an audio amplifier, digital audio amplifier with the Raspberry Pi, the Raspberry Pi doesn't have an M clock output. And so you want something that can take the bit clock and PLL it up. And then, if it can calculate like how much, the main clock frequency it needs based on the bit clock, and does it automatically. So there are existing I2S chips that do that, but many chips require an M clock. What I really like about this one, if you go back one, it doesn't need it. It just needs left right clock, bit clock, and then you see there's SDI and SDO. That's because it can route the audio output. It doesn't actually have a microphone input, even though there's a data output. You only need 3 digital inputs to control the I2S. Okay, typical use case. So like I said, I like how simple it is. Because it's a Class D, and especially if you're using longer wires, you're going to want that LC filter. In the documentation, they do mention you can use ferrite beads. You don't need to use big inductors, but the eval board does use fairly large 10 microhenry inductors and capacitors to make a filter. Probably for EMI reasons, depending on your product. If you're going to be doing EMI testing, you might be able to get away with shorter, if you're using very short wires. Not use power inductors, you can maybe use ferrite beads, but that's on your design requirements. So, probably you can use either, but because this is designed, maybe for stereo systems that go in automotive or whatever, they're expecting to have a lot of noise that can be coupled in, or that it could couple into something. So they want to be extra careful on the output to make sure that they don't get that 1.5 megahertz PWM square wave emitting all over the place. You can also, turns out, connect it into like dual bridge tied loads. So it is bridge tied output for stereo, but if you want like 50 watts, you can get that by tying both the positive and negative outputs of the left and right channel together. And then you can configure it over I2C to say, hey, I want you to do mono output. You can drive, I think, 4 ohms with that dual bridge tied load. Otherwise, if you're using stereo, 8 ohms where it's at. Although it's a little unclear, maybe you can use 6 ohm or 4 ohm as well. It just won't be as efficient. You're going to get the most efficiency with 8 ohms at 20 watts. You'll get, 95%. Another thing to watch out for is the total harmonic distortion. Depending on your power supply, your how much power you're trying to push through, and your load resistance. On the left, it's 8 ohms. On the right is 4 ohms. You want to keep it, under 10% total harmonic distortion, or you can actually start to hear the effects of the crackling effects. But up to 18 volts, you can still get 30 watts into 4 ohms, and if you want 30 watts into 8 ohms, you'll need 24 volts. Okay. Some nice things. I2C interface means you can set things like the gain over I2C instead of like digitally by changing your max integer value on I2S. Of course, there's lots of other settings available, you know, like what format you want, whether you want that mono mode or stereo or mute. But you will need a driver for the I2C interface. One cool thing that this chip does have is dynamic compression. I'm trying to remember what the dynamic range compression. So, you know, one issue that people have when they have these very powerful amplifiers is that it's very easy to um, have clipping when you get to the higher amplifications. If you know, if you have an all-in-one system, you know, you can probably tune it so that you'll never generate an audio signal so loud that it would clip on the output. But if people are using the wrong power supply or they're using different spec speakers than you expect, you could have clipping, and you want to avoid that because it sounds terrible. And so what you can set up is this dynamic compression that as the signal gets louder and louder and louder, it doesn't amplify as much. So you see there's this cutoff where after DRCT, that whatever gain or volume, it starts compressing the amount of gain to be lower and lower. And so you never hit that clipping rate where you might get square waves into your audio signal. It's also got a compensation filter, which is kind of nice. So the output LC filter does have a slight effect on the audio, especially at high frequencies, because you don't have perfect inductor and capacitor. And so, you know, if you can measure the effective transfer function that is caused by that LC filter on your audio, you can then pre-compensate it. And so you get a little bit of a gain at the high frequencies to get, you know, to basically have an even equivalent DC gain across all frequencies. Let's see. Oh, there's an error mode, which is kind of nice. So you can, of course, because there's I2C, you can read from it, not just set settings. And so there's a couple different error modes. You know, it can flip up that GPIO. You can read it. It'll tell you you have open circuits, you know, shorts. You're missing I2S data. You have a DC voltage where it's not supposed to be. So that's kind of nice. Good if you're trying to have a better user interface for people, especially again, if people will be doing their own installation with this amplifier. And I did notice that there is a kernel module written by the Rich Tech team that was submitted into mainline in 2021. And so if you want to use this with a single board computer and it's running Linux, you don't have to do any work because you'll already have a sound driver that's built into the kernel ready to go. Finally, there's an eval board. You want to get started quickly. Big chunky connections for power and speaker output, and then you can just control it over I2C and give it I2S data, and you're good to go. Nice looking eval board, also in stock.
Available on DigiKey.
And the price is nice. It's like $2 to $3 in quantity. You know, $3 for small, $2 for large quantity. That's a pretty good deal for
Not too shabby.
stereos, I2S, no M clock needed, 30 watts or 50 watts mono stereo I2S amplifier. So a nice chip, Class D. Check it out if you need a big honking stereo system.
This is a good INFPA. Good work.
Nice one.
Yeah.
I on NPI.
Okay, let's see how many Raspberry Pis we have before we go off
I
to
guess
the
just a
product
little
line.
check in.
There are 33 in stock. Still got a little bit more time.
Still to go.
Don't forget the code is CAMS. And speaking of, let's bounce over to new product.
Okay. New. First up, we have a revision. The long-awaited 3.5-inch TFT Featherwing is being revised. It's de-zombified. Going to be back in stock tomorrow. But if you're watching this on YouTube, it's probably in stock by then. So you've got a touchscreen, 3.5-inch, 320 by 480 display, beautiful color. And it's got a resistive touchscreen. So if you go to the back of the board, this is V2, which you can tell because it says V2. A few updates. The the STMP touchscreen controller got discontinued over COVID and we couldn't get any more. Now it uses the TSC 2007, which is great, works over I2C, so it's going to be even better for most microcontrollers because You don't need a separate chip select line, and also you don't have to interrupt the SPI to the display, so you'll probably get better display throughput. There's an IRQ now connected to where the chip select used to be. We also added a STEM IQT port, and we made the reset button right angle. The backlight driver also got updated, so it's going to be a big upgrade. You're going to need to, if you're using the touchscreen, you'll need to update your firmware. We have Arduino and CircuitPython code, but the STMP touchscreen controller, like I said, has been totally amazingly discontinued to the point that we could not buy any more. But I'm excited to bring this product back to life.
Okay, and then we got cameras.
Okay. Also coming soon, we have a range of different OV5640 cameras with different lenses. So all of these have the same quality. All the chip underneath is the same. The sensor module is the same, but the lenses vary. So this one, so let's go from the beginning, and I'll talk about each one. This one is 120-degree, so it's like a wide angle lens, and you see that metal ring around it, that metal case. That means it has an autofocus motor in it, which means that you can load firmware onto it that you can then tell it, I want you to go into an autofocus mode, and it will be able to do like close-up photos better because it can move the lens back and forth. Not a lot, like a teeny bit, but it does have some autofocus capability, which could be kind of cool to play with. So yeah, that's that version. And then the next one, this is a 120-degree lens also, so kind of like wide angle lens. And you'll notice it doesn't have that metal casing. That's because it doesn't have autofocus. It does, however, have slightly better distortion management. So we have like a fisheye 120. This is a non-fisheye. It's still somewhat fisheye, but it's like less distortive around the edges. It has more of like a deep hallway look than like a fisheye look. So that's this one. And then this is, you can see this lens is flatter. This is a 72-degree, so no fisheye, no wide angle. It's like what you would normally consider like a one-to-one camera. And this one also has autofocus. That's, you can see the metal case. And then this one is the chunkiest. It's the 160-degree, super ultra wide angle, very distorted, but great for like if you're making a security camera or a wildlife camera and you want to get, a whole almost 180-degree camera view, even if you don't care that it's not like perfect for like photography.
That's cool.
That's one-to-one. So I thought I would show on the overhead. I have so let's
Do it.
so this, okay, hold on. Let me unplug this. I'm going to plug in the least distorted and then move my way up.
I'm gonna.
No, wait.
While you're doing that, I'm gonna show
Okay.
these wonderful photos.
They're wonderful photos. Okay, so I'm going to plug in the first one. So bear with me because this is, I have one board to demo with, and so I have to swap them out, but I can't hot swap them. Okay, so let's see. Okay, so this is okay, so this is the the 72-degree. So like, my face is not distorted. I can like zoom in. My face is not distorted, and you see it's like a very narrow band of what you can see. It's just like what's around my head. So this is 72 degrees, and I'm upside down because the camera's just flipped. Okay, so then I will do the 120-degree, somewhat low distortion. Hold on one second. Sorry, just taping this down and then putting it in. Okay. This one is, okay. So this is 120 low distortion. So you can see now, you see way more than just my head. You can actually see Mr. LadyAda. You can also see a little bit of the camera. And the center is not too distorted. Like, you'll see compared, it is somewhat distorted, but is not as much as, I'll show maybe in a bit the 120 that's more fisheye. Okay, so next up, I'm going to remove this one. And then I'm going to plug in. So this is, gosh, they look very similar. This is, I think, the 120 fish eye. So this is, okay, get this centered. Okay, this is the 120 fisheye lens, so it's got like a more flat look. It doesn't have like a hallway look. But as you get to the edges, like things start to like get, like they get bigger, especially like if you look at faces. And then I'm gonna do the 160, and you're gonna see it's like significantly different. So the 160 is this one. Last camera to go. Nothing harder than inserting the last camera of the batch.
Impressive.
Okay. So this is the 160, and this one is like very distorted. So you can see now, you can definitely see Mr. Lady's head, you can see the closet, you can see the ceiling.
Yeah.
So this is, you get almost like 180 degrees, but obviously if you're taking photos of people, you're like, your head is so tiny and your hand is so big. But that's the trade-offs with the lenses. So
Okay.
they're all the same breakout, breakout board. Let's see this one. They're all the same breakout board. This one I've soldered the headers onto. We've got code for the ESP32S3 and the RP2040. To use these cameras, you do need to have a microcontroller that can handle the 8-bit interface. So not every microcontroller can do it. It's a standardized interface, but we really only recommend using the RP2040 or the ESP32S3. And on the back, if you're using autofocus mode, just short the VM jumper, and that will let you load the firmware that makes the autofocus work. So you'll just notice the autofocus ones have the metal body outside, and then the non-autofocus have the lens. Note that the lens does screw in if you really wanted to change the focus, but the default is infinite focus, and it's good for like 99%.
Okay. And with that is new products of the week.
Yay! New.
All right. Don't forget cams. That's the code.
Cams. Why
Stuff.
did you say those cams?
Yeah. Also, let's do a quick Raspberry Pi check. It looks like we have exactly 30 left in stock.
Wow,
So
you
just a
like
little bit of
it's an
time.
hour.
Yeah. So what we're gonna do next is we're going to play some top secret videos, and then we'll go to the questions. You can post them in Discord. I've been stockpiling the ones away that were in there earlier in the chat, but we'll see you over there in a moment. Here is top secret.
All right, Lady Ada, what's this?
This is a blinking LED. No, it's a blinking TFT. This is a round 2.1-inch TFT, and I just have it turning on all the pixels white and off. And the reason I'm doing that is I'm actually trying to debug this, which is trying to get the large 4-inch screen working with the ICN 6211, and it's not working, and I don't know what's up, and I think it has to do with the screen initialization, which happens over SPI. But the problem is I've got Raspberry Pi, kernel, device tree overlay, ICN configuration, SPI configuration, AT time. There's too many variables. So what I do is I'm actually testing this out first on a known working platform, because I'm always like, start with a known working thing, change one little tweak to figure out what's going on, and then adjust and adapt until you figure out exactly what your root cause is. And I actually don't have the ESP generating any TFT signal. What I'm just doing is the SPI configuration. And if you look over here on the data sheet, sorry, all pixels on, there you go. There is this mode called all pixels on, which will turn on all the pixels for you, and you don't have to have TFT signal, it just does it directly from the SPI commands. And so over here, what I've got is a little bit of code that sends the init sequence, but then it appends to the init sequence the command to turn all the pixels on and off. And so now that I know that that init sequence is good, I'm going to move that code over to the ATtiny over here, and that'll let me know whether I've got the SPI init code and wiring working, and then I can work backwards, fix the ICN, fix the device tree overlay, and basically get it all working with a Raspberry Pi.
Lady Ada, what is this?
This is the biggest blinking LED. Now, this is
Hello world.
I know.
Hello world.
This is a 4-inch round TFT display, and I'm trying to get it working through the ICN 6211 with a Raspberry Pi 5 through the DSI converter. DSI converted to the ICN, to TTL, to this TFT. And there's 3 things I gotta get working. I gotta get the device tree working on the Raspberry Pi. I've got to get the ICN config burned into this over I2C, and I've got to get the SPI configuration on this TFT. And what I'm testing now is the SPI configuration. So what I've done here is, I write the SPI init code. I'm using like an ATtiny, and then I have a loop down here where I'm just sending the MIPI SPI commands 22 and 23. And what those do is turn all the pixels on and all the pixels off. So I've isolated just making sure that the SPI init working. Next, I'm going to do the ICN configuration.
All right, LadyAda, what's this?
There's some beautiful color bars. This is the color bar demo register setting for the ICN 6211, which is the chip that I'm using to convert DSI from the Raspberry Pi 5 to this RGB TTL display, this 4-inch round 720 by 720. I just got the SPI init code working. Turns out you have to set the bits in the order that they come in. Who would have known? So once that got working and had all the LEDs turn on and off, the next step is to verify that this config works. And so you have to set the resolution and the VSync, HSync, whatever porches, PLLs. And then there's a bit you can set called the BIST mode, where you can set different tests. So this is the, searching color bar, chessboard, outline, and color switch. And these allow you to test that the TTL connection works. So I'm still not using data from the Raspberry Pi yet. This is just running directly from the ICN 6211. I am programming it using Blinka from the Raspberry Pi using I2C, so I can try all the different settings. So far, so good. So SPI works, I2C works. The last piece is to get the device tree overlay going.
All right, LadyAda, what's this?
This is the Raspbian Bookworm desktop working on this large round 720 by 720 display. I got the SPI networking, I got the ICN 6211 I2C working, and I've got the device tree overlay working. All 3 things together mean that we now have a working display, and I've got a little mouse plugged in. And what's cool is, this is a full Raspbian build, so it's got all Linux support. So you sent me a file you wanted me to play on here.
I just regularly send you Stargates.
You basically send me a Stargate every morning.
Yeah,
it's kind of
Stargate.
weird. What's up with that? So just because the screen is small, what I can do is I'll loop it and I'll make it full size. And wait a second, and the auto thing will disappear. And now we've got your very own video Stargate, something you've always wanted.
Yeah, look at this.
Yay!
That's cool.
Yeah. So so far so good. So just have to repeat this for every display. But so far this cool round display is working very nicely.
Yeah.
On Linux, Raspberry Pi.
Here we go.
Going into space.
Chevron's locked.
Do they make a noise?
What?
Pew,
They
pew,
do.
pew. I don't know.
They do.
Okay, activated. Let's go
Yeah.
into space.
Cool. All right, LadyAda, what's this?
This is a 3.5-inch 480 by 320 capacitive touchscreen. So we just wrapped up the revision for our 3.5-inch 480 by 320 version of the resistive touch feather wing and the breakout. And I realized that I actually had a bunch of these kind of nice capacitive touch displays. So this is one part of the test where I load a image off of an SD card. Let me reset it. You can see it's a little slow because this is running off of a Mega. And that tests the SPI interface mode. And then I can flip this switch over here. You can see 8. And then it will test it in 8-bit mode. And that's also testing the capacitive touch interface. This is actually a multi-touch, although this demo only shows a single touch. It actually can recognize 5 fingers. So this is built on a Mega. And you can see there's a lot of GPIO used here. That's why I need a Mega. It's lots of big because it's using both the SPI and I2C and 8-bit interface. But so far so good. So this is ready to rock. I'm going to finish the adjustments for the tester, and I'm going to order this, and I'll be in the Adafruit shop soon.
Really? What's all this?
I am updating a whole bunch of testers. Not only did I have to do hardware revisions for boards like the Clue, which I'm still working on, the Feather, NRF52840, and the Itsy Bitsy, But well, I'm supposed to actually also be Pico-ifying the testers, but and more importantly for me right now, I am updating these testers to install the latest Teeny UF2 bootloader onto these boards because the bootloader needs a couple of adaptations to be able to load the latest version of CircuitPython because the binary got larger. And so it's not trivial for people to update the bootloader, although you can do it. You just have to run it in Arduino. So instead, what I've done is I have, reburned the test binaries and I'm updating this SD card. So now when I program it, it still does all the same programming and test, but the final version of the code that gets loaded onto the Feather is going to have the most latest bootloader. So see, it's programming final and passed. So we're going to reprogram all these boards and get them back into the Adafruit shop updated.
What's going on this week?
Back in the vault.
Okay, we have the questions lined up.
Ask them.
I know the show's running a little late, but we're gonna
Yeah,
still get to them all.
Thank you.
We do. Okay, so let's go with the handy dandy. Questions. So, question: will the 2.8-inch TFT touchscreen PAD 1651 work with Metros like the recent Metro ESP32S3?
Yes, it will work with all Metros and Arduinos as long as they have the I2C port. Like as of like 10 years ago, they
Okay.
all do.
Someone,
And SPI pins.
someone know is what is international shipping costs? Well, first off, let me just because I think they you could just add the stuff to your cart and then you can get the estimate right there. I would suggest you go to adafruit.com/distributors because if you're in Australia, which I think this person was, it is expensive to ship anything from the US to Australia. It just is. There is no way around it. I don't even think they do any forms of free shipping for anything to Australia. So check out our resellers in your local area. That's always the best way. You can also check DigiKey, Mauser, Arrow, other places. But you can always get a cost estimate on our site before you check out. Next up, what's the secret to the TVB GON's long range with two AA batteries at 3 volts? Is it something with the capacitor?
Big transistors. Also, TVs are really, really good at picking up infrared signal because of the modulation that they use. Like TVs have over the last few decades have just like improved. And so, yes, big transistors and a drive transistor to drive the transistors, but also TVs are very sensitive.
Okay. For the refresh rate on the camera, what determines that?
So this is not the fastest demo. This is an older CircuitPython demo, which I was supposed to update and I got distracted playing Wordle. So instead of working on that, it can be faster. The ESP32S3 is basically like 20 frames a second. The RP2040 with the CircuitPython code is kind of manually moving the data around. So it's maybe 3 or 4 frames a second, but you can definitely get 10 FPS. Although I'll say, like I said, using it on the RP2040 is a little bit of a hack. We're using PIO to like bit bang the data. So you can get fairly fast data, but the ESP32S3 actually has a peripheral for handling the camera, and so it's a little bit faster, I find.
Okay, next up, any news for my little hacker ESP32S2 development board? Yes, we wanted to. The hardware's done. The software needs to catch up, and
Yeah.
we were waiting to merge in the.
We had some
IDF5.
flakiness. Yeah, we had a little bit of flakiness. We wanted IDF5 5.1 because it solved a couple of Wi-Fi issues we were seeing. So that's getting merged into CircuitPython, and we're doing releases. And I think once Scott finishes up some of the memory management stuff, him and I will be working on this project.
Okay. Let's see. Thanks. Got that one. And then next up, product suggestion. And I2C Stemma QT latching mini relay. I found various feather wings or Stemma 3-pin relay, but nothing that can do an I2C control. Maybe with Seesaw, I just want to control a doorbell.
Yeah, the challenge with that, just to explain why we haven't immediately done a relay over Stemma, is the Stemma cables are really thin and they're not really meant for driving powerful things like motors or solenoids or relays. And so if we do a relay, whereas the JST-PH cables are much chunkier and they can handle an amp or two. If you're going to do it, it's the risk is that people will be like, oh, it's really flaky because the voltage dips through the long thin wires because they'll be like, oh, I want a meter long cable and they're 28 gauge. So making sure that people have a good experience is a tough part.
Okay. And then last question that just came in the other chat is the Stomach QT connector 5 volts compatible or only used for 3.3 volts?
It's a good question. Every device that we make, like sensor or like LED driver or whatever PWM controller that has a STEMMA QT and it says STEMMA QT on it, can be used with 5 or 3 volts. We make sure that they're all 5 and 3 volt compatible. However, if you have the driver, the controller, like the Metro or the Feather, those don't always give 5 volts on the power pin. They usually use 3 because they use the logic level. So it's like the devices can take 3 or 5, but the controllers tend to only be 3 volts. So it's mostly of a matter of compatibility. If you have a device that's giving 5 volt power, 5 volt logic, you won't damage a STEMMA QT sensor. But that doesn't necessarily mean that we'll always get 5 volts. Depending on what you control it by, you might get 3.
Okay.
Makes sense.
And that is all the questions this week.
Okay, we did it.
Yeah.
Ran a little long, but I think we had a lot going on. A lot of
Lots going on.
videos.
Okay, little quick check.
Still.
There is 13 left in stock.
Okay.
Replies. Thanks. Don't forget next week you can always do two-factor authentication on your account so you're ready for when we have pies in stock. We're probably gonna do this again. We'll see if we get more in stock. Probably will. We'll see.
Okay.
Unknown unknowns.
This is lasted an hour. That's a pretty good amount.
Yeah. It's been an Adafruit production. Thank you so much. Thank you, Takara, behind the scenes, doing stuff, helping out, and more. Special thanks to all our community, our customers, and everybody who makes this thing go. Thanks for being part of something that hopefully brings people together. World needs it now. See everybody next week. Here is your moment of Zener.